All right, so today we're going to do the paper 4, which is the theory extended option. This is for coordinated sciences, which is a double award. That's IGCSE, and that's Cambridge International Examinations, so the CIE. This is May-June 2018, and this is variant 1, so 0654/41 is the code. Okay, my name is Alicia, and I'll be doing the biology and chemistry parts, and Mike will take over for the physics parts. All right, let's get started with the biology.
Let the games begin.
Question 1a. The lining of the small intestine is covered with villi. Figure 1.1 shows a cross-section of a villus. Using the letters A, B, C, and D in figure 1.1, identify the part where fat is absorbed. Okay, so fat is absorbed in the lacteal, which is A. And glucose enters the bloodstream in the capillaries, which is C. All right. Explain how the shape of the villus is related to its function. Okay, so the villus is, they're very elongated, they're very narrow, and the whole point of that is to increase the surface area for absorption. There's a lot more surface area in a structure like that than there is in just a hollow tube. And all the molecules can only be absorbed in the surface. All right. Okay, it is elongated and narrow to increase surface area for absorption. B. Fats are an important part of the diet. State the smaller basic units that make up fats. Okay, fats are made up of glycerol and fatty acids. Okay, glycerol and fatty acids. The triglyceride is made up of 1 glycerol and 3 fatty acids. Okay. Describe how bile aids the breakdown of fats. Okay, so bile, the purpose of bile is it emulsifies the fats. It breaks it basically into smaller pieces. Then the purpose of that is to increase the surface area for enzymes, specifically lipases, because fats are lipids, to work on. Okay, so the bile emulsifies fats to increase surface area for enzymes, or lipase, to work on. And if you notice, that's the second time the same question that the word surface area came up. Surface area is a very common keyword for this topic. D. A person eats too much fat in their diet. One of the consequences of this is obesity. Suggest a disease that can be caused by too much fat in the diet. And a disease that can be caused by too much fat in the diet is called coronary heart disease. Okay, coronary heart disease. E. One way to reduce the risk of obesity is to reduce the amount of fat eaten. Suggest one other way to reduce the risk of obesity. Okay, and the other way that's really important for reducing obesity, or the risk of obesity, is exercise. Okay, so to increase the amount of exercise. Another thing you can say is to decrease the total number of calories eaten, but basically fat or calories combined with exercise, that's how you reduce the risk of obesity. Okay, but it does only say one other way, and one is even in bold, so you really only should put one down. Question 2. Figure 2.1 shows the industrial electrolysis used to extract aluminium from aluminium oxide. Okay, so this is electrolysis, and you should always, when you look at an electrolysis question, before you even read the question, panic. This is the only time I say you should panic in a science exam. So the positive anode, negative is cathode. I always write that at the beginning of an electrolysis question. Sometimes it tells you what the anode and cathode are, but sometimes it doesn't, and it generally comes up somewhere in a question. A1. Aluminium oxide contains aluminium ions, Al3+, and oxide ions, O2-, so deduce the formula of aluminium oxide. Okay, that's nice and straightforward. You take the number of ions that are on the aluminium, and put it on the oxygen. Take the number of ions that are on the oxygen and put it on the aluminium. So this is Al2 2. Explain why the ionic compound aluminium oxide has a high melting point. Okay, the reason for this is because opposite charges attract, and both of the ions have very high charges. So one has a 2 minus, and the other one has a 3 plus. Those are quite highly charged, much more than, say, sodium chloride, which has just a 1 plus or minus. Okay, so the attractive force is strong. It takes large amounts of heat energy to separate the ions. Okay, so opposite charges attract and both ions are highly charged, so the attractive force is strong. It takes large amounts of thermal energy to separate the ions. Okay, that's explaining it. And 3, compound X and aluminium oxide are mixed together to form the electrolyte. Name compound X and explain why it is mixed with aluminium oxide. Okay, the compound X, that's called cryolite. And cryolite is mixed with aluminium oxide because the mixture has a lower melting point when it's mixed than it does when it's not mixed. If it has a lower melting point, that means less thermal energy is needed to melt it. Okay, so the mixture has a lower melting point than Al2O3 alone, so less thermal energy is needed to melt it. It doesn't take as high a temperature to melt it. 4. Figure 2.2 shows the position of an aluminium ion in the electrolyte. All right, so we have aluminium 3 plus floating around in the electrolyte. Describe what happens during this ion during electrolysis. Okay, so plus moves to minus. And minus, if we remember to panic, as I said earlier, the positive anode, negative is cathode, so this is the cathode. All right, so the aluminum 3 plus ion goes towards the cathode, and when it's there, it gains electrons, so it becomes aluminium. All right. Okay, so the Al3 plus ion is attracted to the negative electrode, called the cathode, and gains electrons. Okay, so each ion gains 3 electrons. So each ion gains 3 electrons, so the equation is Al3 plus 3 electrons produces Al. Okay, that's it. Okay, the anode in the process in figure 2.1 oxidizes to form carbon dioxide. Complete figure 2.3 to show the dot and cross diagram of the covalent bonding in carbon dioxide. Show all of the outer shell electrons in all of the atoms. Okay, first of all, remember it doesn't matter which one's a dot and which one's a cross as long as you're consistent. So I'm going to use crosses for carbon. Okay, so carbon has 4 electrons in its outer shell. And all 4 of those electrons have to be involved in the bonding. Okay, so we have 2 electrons with each oxygen. Because remember, carbon dioxide, the molecule looks like this. It's made with double bonds. So for each electron in the carbon outer shell, there has to be an electron in the oxygen outer shell. So we have 2 electrons for each oxygen taken care of. Okay, but oxygen has 6 electrons in its outer shell. Okay, and each of these electrons has to be paired. So we have 2 taken care of, we need 2 more. So we have 2 more on each one. And remember, the reason why they're in this position is, first of all, they have to be in pairs. And second of all, they want to be about as far apart from the other electrons as they can be. All right, good. That's it, all that at once.
Question 3. Figure 3.1 shows a farmer driving a tractor. The tractor accelerates along horizontal ground from 4 meters per second to 6 meters per second in 12 seconds. The mass of the tractor is 4,800 kilograms. Calculate the force required to produce this acceleration and state the formula you use and show all of your working out. Okay. Right, well, first things first, we've got a tractor which is accelerating. So let's calculate by how much it's accelerating. Acceleration equals change in velocity over change in time. So that's then given by 6 meters per second minus 4 meters per second. Final speed minus initial speed. You know what, let's just write that down as well, just in case there's a mark hidden away for it. So, 6 meters per second minus 4 meters per second over the change in time, we're given 12 seconds, which gives us then a value of 0.167 meters per second squared. Alright, so from that we then have our next part, which is to calculate the force being used. Well, force equals mass times acceleration. Let's just do that. That's going to be 4,800 kilograms multiplied by 0.167 meters per second, which will give us a value, meters per second squared, gives us a value of 802 newtons. It's a very interesting thing. If you take this answer here, because this actually is 1 divided by 6 meters per second, negative 2, but we have to write down a physical number, not just a fraction. If you take this and multiply it by 1 over 6, you get exactly 800 newtons. Here we've got 802 newtons. If you were to do it with 0.17, not 0.17 meters per second squared, to get about 820 newtons. So you see it rapidly becomes more accurate for the extra decimal places. For this one, of course, we're going to use two significant figures. It would work the same and gives 800 newtons whether we use 0.167 or 1 over 6. But something to be aware of is to try and use the most accurate value in your calculation and then round it up to the nearest number of appropriate significant figures when you write the answer down. So that's 800 newtons. 2. Calculate the increase in kinetic energy of the tractor when accelerating from 4 meters per second to 6 meters per second. Okay, well, the formula for kinetic energy is 1/2 mv squared. So change in kinetic energy is just the final kinetic energy minus the initial kinetic energy. So the working out for that would give us 1/2 times 4,800 kilograms times 6 meters per second squared minus the initial kinetic energy, which is 1/2 times 4,800 kilograms times 4 meters per second squared, which gives us then, so our final results, 4,800 joules. There we go. B. While the farmer is on his tractor, he uses a solar-powered charging device to charge the battery in his mobile phone. And here we've got the phone and charger being drawn out. A picture of them. The solar cells are 25% efficient. These produce an output of 0.5 joules to the phone. Calculate the solar energy input per second. Okay, state the formula you use and show your working out. So what we have, of course, is the useful work done is the efficiency multiplied by the total work done. And I can rearrange that to get the total work done, the total energy in, is going to be equal to the useful work done, or the useful energy out, divided by the efficiency. Alright, so now I can put that information in and work it out. That's 0.5 joules divided by 25% efficient is 0.25. Gives me a value of 4.0 joules. There we are. And there we go. C. The farmer uses a lens to focus the sun's rays onto dry grass to light a small fire. Alright, so draw the rays of light after they leave the lens. There we go, that's that one done. They're coming together where you can see the smoke coming up as it's obviously starting to start a fire. I didn't go through drawing the lines of the rays inside the lens. In fact, you would never do that anyway. what you would do as a general rule if you were asked to is you would draw as if there was a line through the centre. Oops, line through the centre, and then you would use that as your line. It didn't ask us to do that though, it just asked us to draw the lines after they leave the lens. That's why I haven't drawn anything inside the lens there. The lens produces a real image of the sun. Describe the difference between a real image and a virtual image. The main difference between a real image and a virtual image is a real image can be projected onto a screen. There we are.
Okay, welcome back to the biology. Question 4, figure 4.1 shows the number of cigarettes smoked per person per year in the USA. Figure 4.1 also shows the number of deaths per 100,000 people per year caused by lung cancer in the USA. A1. Describe the trends in deaths by lung cancer shown in figure 4.1. Okay, so we're describing the trends in deaths, not the trends in cigarettes smoked. So, if you look at it, the number of deaths from cigarette smoking, well, from lung cancer, increased steadily until get to 1990. And then in 1990, there was a peak of deaths and then it decreased. Okay, let's write that in. Okay, so the number of deaths due to lung cancer increased steadily up until 1990. They peaked in 1990 and then decreased. All right. Okay. 2. Suggest 2 reasons why the number of cigarettes smoked per person decreased after 1975. So first of all, after 1975, there was more advertising about the links between lung cancer and smoking. Okay, so there's more advertising about the link between lung cancer and smoking. And because of that, people became more aware of the link between smoking and lung cancer. Okay, so more advertising about the link between lung cancer and smoking made it so that people became more aware of the link between smoking and lung cancer. B. Suggest why there is a lag between number of cigarettes smoked and lung cancer deaths. So this is what it means by the lag. So this is the peak of number of cigarettes smoked, and this is the peak in the number of deaths. The peak is later. Okay, it's the same shaped graph, but it's a different time. So the lag means it happens later. And the reason for this is that lung cancer does not happen instantaneously. It takes years to develop. Okay, lung cancer takes years to develop. All right, let's move on. C. The boxes on the left show components of tobacco smoke and the boxes on the right show their effects on the body. Draw 4 lines to link the components of tobacco smoke to their main effect on the body. Okay, so carbon monoxide, what does it do? What it does is it pretends to be oxygen, so it takes up the place of oxygen, so it reduces the ability for the red blood cells to carry oxygen. So it reduces oxygen carrying capacity of the blood. Okay, nicotine is what makes cigarettes addictive. Okay, the smoke particles, they're big and they irritate the lining of the lungs and the trachea, so they're an irritant. And the tar is full of lots and lots of chemicals that stick to the sides of your airways, and it causes cancer. All right, that's it. D. Explain why smokers are more likely than non-smokers to develop bacterial lung infections. Use the words cilia and mucus in your answers. Okay, so the cilia become damaged by the tar and are not able to remove the mucus. Okay, cilia become damaged or not able to remove mucus. Well, there we go. We have the word cilia and the word mucus in our answer. Okay, because of this, the mucus builds up and mucus is sticky, so it traps bacteria. And that bacteria then does what bacteria do, and it multiplies and causes infections. Okay, so the cilia become damaged and are not able to remove the mucus, so the mucus builds up and traps the bacteria, and bacteria multiply and cause infections. And that results in lung infections. Okay, And that's the end of question 4. Let's move to question 5 for chemistry. 5a. Complete the general equation for the reaction between an acid and an alkali. So an acid plus an alkali produces salt plus water, and water's neutral, so that's a neutralization reaction. Okay, salt plus water. Okay. B. Table 5.1 shows the aqueous ions contained in dilute hydrochloric acid and in potassium hydroxide solutions. Hydrochloric acid has H plus and Cl minus, and aqueous potassium hydroxide has K plus and OH minus. So you need to construct a balanced symbolic equation for the reaction between dilute hydrochloric acid and potassium hydroxide solution, and include the state symbols. Okay, this means you can't do a word equation. That's what it's saying. Okay, so we start off with HCl, and that's aqueous, it says, plus KOH, which is also aqueous, and that produces KCl, which is also aqueous, plus H2O, which is a liquid. It's not aqueous because it is water. Aqueous means dissolved in water. You can't have water dissolved in water. Okay, so it starts out with hydrochloric acid plus potassium hydroxide, so acid plus alkali. We have our salt, which is potassium chloride, and water. So there we go. That's our neutralization reaction. Identify 2 ions that combine to form a covalent compound in this reaction. Okay, so the 2 compounds formed, we have KCl, which is a salt, and water. Okay, now salts are ionic. Okay, we have the pluses and minus held together by their bonds. Okay, H2O, they share their electrons. Okay, so water is covalent. So we have our H plus, or we could say hydrogen, and we have our OH minus, or we could say hydroxide. Both of those are okay. All right, good. Part C, dilute sulfuric acid reacts with magnesium to release hydrogen. Okay, the equation for this reaction is shown. So we have H2SO4, which is sulfuric acid, plus magnesium produces MgSO4 plus hydrogen. So complete the steps in the calculation below to find the volume of hydrogen gas that is produced when 0.072 grams of magnesium reacts in excess dilute sulfuric acid. So step 1 is to calculate the number of moles of magnesium in 0.072 grams. Okay, so the moles, the equation for moles equals mass over relative molecular mass. Okay, and that equals 0.072 grams over, if you look at the periodic table, 24 grams per mole. If you're unsure where to find that on the periodic table, we have magnesium right here, and we have the mass number right here of 24, which shows the number of grams per mole. So 0.072 divided by 24 grams per mole, that equals 0.003 moles. Grams cancel out, and you're dividing by moles to minus 1, so it's moles. So the number of moles is 0.003 moles. Okay. So state the number of moles of hydrogen gas produced when 0.072 grams of magnesium reacts. Okay, so let's look at this. Okay, so we had 0.072 grams of magnesium, and that is 0.003 moles. And that's all of these is a 1 to 1 to 1 to 1 ratio. Okay, so if 0.003 moles of magnesium reacts, it produces 0.003 moles of hydrogen. So the answer is 0.003 moles. Okay, step 3, calculate the volume of hydrogen in decimeters cubed produced when 0.072 grams of magnesium reacts. And the molar gas volume is 24.0 decimeters cubed. Okay, so the volume equals the number of moles times the molar gas volume, because we're dealing with a gas. Okay, so that equals 0.003 moles times 24 decimeters cubed per mole, which equals 0.072 decimeters cubed. So the answer is 0.072 decimeters cubed. All right, so state the name given to the number of atoms contained in 1 mole of magnesium. So the number of atoms in 1 mole of magnesium, that's called Avogadro's number. Okay, good. And that's it.
Question number 6. The wind turbine generates alternating current electricity. We've got some electrical component. Put a tick next to the 2 components that an electrical generator must contain. Well, if you're going to generate electricity in this form using a wind turbine, then you would need a changing magnetic field, so something with a magnetic field around it, and a conductor. So there we go. We've got a wire coil and we've got a magnet. The coil of wire just means that you get more bang for your buck, if you will. Makes it easier to generate a large voltage. When electricity has been generated, a step-up transformer increases the voltage before the electricity is transmitted through cables to a nearby town. Explain why the voltage of the electricity is increased before transmission. Alright, well, specifically it's to reduce power loss. Maybe let's just explain that a little bit more clearly though. Power loss is given by I squared R. What we know is that power equals I times V. Now, for this, as the voltage increases, the current decreases. And that means that less power is lost in transmission. So power lost equals I squared R. Power is current times voltage. As the voltage increases, the currents decrease, obviously for the same power. So the power lost decreases. Less power is lost in transmission. The output from the wind turbine is 700 volts. The voltage is stepped up by a transformer. The number of turns on a primary coil of the transformer is 28,000. The number of turns on a secondary coil of the transformer is 440,000. Calculate the output voltage from the transformer. Right, state the formula and show you working. Okay, so what we need is our equation for transformers. And that's the voltage in the primary divided by the voltage in the secondary has the same ratio as the number of turns in the primary divided by the number of turns in the secondary. What we would do is we take that, because we want to find the voltage in the secondary coil. So we rearrange that, and that gives us Vs equals Vp times Ns all over Np. Now we can do our working out. Voltage in the secondary coil, 700 volts times 440,000 tons divided by 28,000 tons, which is the number in primary. There we go. And that gives us a value of 11,000 volts. There we are. C. Wind turbines are noisy when they are turning. When they turn faster, the sound waves emitted have a larger amplitude. State how the loudness of the sound waves of the wind turbines change when the amplitude of the sound waves emitted increases. Alright, amplitude. Well, amplitude, if you like, is a measure of how much energy is being transmitted. So as the amplitude increases, so does the loudness. D. Sound waves pass through the air as a series of compressions and rarefactions. State what is meant by a compression. Alright, well, a compression is an area of high pressure, a rarefaction is an area of low pressure. So compression is a high pressure area. And 2, describe the wavelength of a sound wave in terms of its compressions. Right. Just do a little diagram down here so I can explain it. And I'll say let's put 5 together for a compression. 1, 2, 3, 4, 5. Then 5 further apart. 1, 2, 3, 4, 5. Then 5 together. 1, 2, 3, 4, 5. Then 5 further apart. 1, 2, 3, 4, 5. Then 5 further goes together. 1, 2, 3, 4, 5. If I was to draw this as a wave, what this represents, there we go, would be like this. That's it. And of course the wavelength of our wave is then between here and here. So it's the distance between 2 compressions. There we are.
Question 7. Figure 7.1 shows apparatus used by a student to investigate the rate of reaction between excess dilute hydrochloric acid and a piece of limestone. Okay, so we have a flask. We have the reaction occurring in the flask. There's a stopper on the flask, so all the gases get bubbled and pushed down underneath the water so we can bubble up, and this graduated cylinder was completely full at the beginning of the reaction and fills up with carbon dioxide as the bubbles are released. Okay, and then you can measure how much gas is produced during the reaction, except for what dissolves in the water. Okay, the student measures the volume of gas in the measuring cylinder every minute for 9 minutes. Her results are shown in figure 7.2. So that is this graph right here. So as you can see, the rate of reaction was quick and steady, and then it started to slow down until it reached a maximum and there was no more reaction occurring. All right. A1, name the main chemical compound in limestone, and that is calcium carbonate. Okay, name the gas that collects in the measuring cylinder, and that is carbon dioxide. And that is because the carbonate is CO3, so the carbon dioxide comes from the carbonate. B, the student uses excess dilute hydrochloric acid. 1, use figure 7.2 to deduce the time taken for half of the limestone to react, and explain your answer. So if you look at this, the maximum amount of carbon dioxide that was produced was at 44 centimeters cubed. Okay, so for half of the limestone to react and produce calcium and produce the carbon dioxide, that would be, half of that would be 22, and that is right about here. Okay, now if we look at the time there, that is at 1.4 minutes. Okay, so half of the amount of limestone to react, that would produce 22 centimeters cubed of gas, and this is at 1.4 minutes. Okay, good. Okay, so the time taken was 1.4 minutes. Okay, and the explanation is that this is the amount of time for half of the maximum amount of gas to be collected. Okay, this is the amount of time for half of the maximum amount of gas to be collected. Okay, 2. The graph shows that the rate of reaction changes. Explain, in terms of particles, why the rate of reaction decreases. Okay, the reason for this is because as the reaction progresses, the number of particles that can react decrease because the concentration of the reactants has decreased. This means that there are fewer collisions, and so there are fewer reactions. Now let's write that down. Okay, over time there are fewer reacting particles as the concentration of reactants has decreased. This means that there are fewer collisions, so there are fewer reactions. Okay. C. Lime is produced from limestone in a lime kiln. Figure 7.3 shows a lime kiln. Okay, so inside this vessel we have carbon, which acts as a fuel, and limestone. We have air coming in through the bottom, containing oxygen, and the waste gases are expelled through the top. Okay, now when we're talking about a fuel and air, we're probably talking about combustion. So 1. Identify the exothermic reaction and the endothermic reaction occurring in the lime kiln. Okay, so the exothermic reaction is the combustion of carbon. Because carbon is acting as a fuel, that's what's being combusted. Okay, so the endothermic reaction is the decomposition of calcium carbonate. So the limestone is breaking down because of the heat, but it's absorbing the heat. So it's an endothermic reaction. Okay, so the exothermic reaction is the combustion of carbon. The endothermic reaction is the decomposition of calcium carbonate. Okay. 2. State the energy change that occurs in an endothermic reaction. Okay, so it goes from, it starts off with heat energy, so thermal energy, and it is converted to chemical potential energy. Okay, so it starts off as heat energy, thermal energy, and it goes to chemical potential energy. 3. Explain why the mixture of waste gases contains a large amount of nitrogen. Use the idea about reactivity in your answer. So the air that we breathe and the air that goes into the bottom of the kiln contains a large amount of nitrogen. And nitrogen is very unreactive. It doesn't burn, it doesn't react, and because of this, what goes in, pretty much most of it remains as nitrogen at the end. Okay. So nitrogen is present in the air. Nitrogen is very unreactive, so it doesn't burn or react, so it remains at the end. All right. Question 8. A farmer has a group of rabbits. The coat color of the rabbits are recorded. Table 8.1 shows the results. So we have black, white, gray, and brown rabbits. So we need to calculate the percentage of rabbits with white coat color. Okay, so we have to show our working as well. So the percentage of white rabbits is the number of white rabbits over the total number of rabbits times 100. So the percent white rabbits equals the number of white rabbits over the total number of rabbits times 100. Okay, so if we look at the numbers for that, that equals 15 rabbits divided by 13 plus 15 plus 33 plus 14 times 100. So that equals 15 over 75 times 100, which equals 20%. So the answer is 20%. 2. State the type of variation shown by the rabbits in table 8.1. Okay, so we have different categories rather than a nice smooth continuum. So this is discontinuous variation. All right, and 3 suggests the cause of the type of variation stated in your answer to A1. Okay, well, discontinuous variation is caused solely by genes that are inherited. All right, so B. The farmer breeds some rabbits. One of the rabbits is born with an orange coat color. Suggest a cause for this unusual color. And the cause of an unusual color is called a mutation, a gene mutation. All right, good. And C, the rabbits with brown coat color are the most popular and are sold for more money. Describe what steps the farmer could take to increase the number of rabbits born with a brown coat color. So first of all, what they do is the farmer could select rabbits with brown coats and allow those rabbits to breed. And then the farmer will select the offspring of those rabbits that have brown coats and allow those ones to breed. And he will do this over many generations, and then pretty much the only rabbits he'll have, other than a few mutations, are most likely to be brown coat color. Okay, so the farmer will select rabbits with brown coats and allow them to breed, then select offspring with brown coats and allow them to breed. Then they repeat it over many generations. All right, that's the answer to that question. Now it's physics.
Question 9. Figure 9.1 shows a washing machine connected to a 230 volt supply. The washing machine uses 2500 watts of power when operating. Name the unit with the symbol W. Well, it's watts. 2. Calculate the current when the washing machine is operating. State the formula you use and show your working. Alright, well, we've got power, we've got current, so we can use power equals current times voltage. And of course we want to find the current, so we'll rearrange that. It's power divided by voltage. The working, current is 2500 watts divided by 230 volts, which gives me a value of 10.9 amps. Looking at this, so two significant figures up top, so I'm going to want to use two significant figures, 11 amps. Now, inside the washing machine, the water is heated by an electric heater. Describe in terms of particles how thermal energy is able to pass through the metal parts of the heater. Alright, let's use our approach then. Something happens which has an effect, which means therefore. So something happens, well, as the temperature increases, the particles, which happens, so something happens which has an effect, well, as the temperature increases, the particles vibrate more. Which means, well, vibrating particles will pass the vibration onto nearby particles. Therefore, the vibrations and the heat, because that's what the vibrations are really, passed on through the material. There we go. C. The washing machine is filled with 15 kilograms of water at an initial temperature of 20 degrees C. The energy required to heat the water to 60 degrees C is 2520 kilojoules. So 2520 kilojoules. Calculate the specific heat capacity of water. State the formula you use, show your working, and state the powers of units in your answer. Alright, now let's look at this. The formula that we're going to need for this is E equals mc delta t. Or you may know it as E equals mc delta theta. Both are absolutely fine. And of course we can just use our triangle method to rearrange it. Absolutely fine. There we go. Beautiful little triangle. We want to find C, so we just cover it over, and that tells us that C is just E divided by m delta t. So the energy put in divided by the mass multiplied by the change in temperature. Okay. So let's look at that a bit further. C is then given by the energy, 2520 kilojoules, that's 2520 times 10 to the power of 3 joules, divided by the mass times the change in temperature. Okay, we've been given it in kilograms, so I'm just going to do this in kilograms. So 15 kilograms multiplied by the change in temperature, that's 20 degrees C to 60, so 60 final minus the initial. So that'll give us 40 degrees Celsius. And if I put that through, that'll give us an answer of 4,200 joules per kilogram per degree Celsius. There we are. 4,200 joules per kilogram per degree Celsius. Now, you could of course have done this using grams. That would be 15,000 grams multiplied by 40 degrees C, and that would give you an answer of 4.2, and the units then would be joules per gram per degree Celsius. There we go, two different things you could have for the units, both of them absolutely acceptable. And you could even put in degrees Kelvin, but I'm just going with degrees Celsius because they've been very clear in question that that's there. There we are. Okay. Let's move on to part D. D. Some wet clothes are hung outside on a line to dry. The water still in the clothes is able to evaporate. The water evaporates more quickly on a warm day than on a cool day. Describe and explain why warm conditions increase the rate of evaporation. Alright. So now on these little explanation questions. Something happens which has an effect, which means therefore. Let's look at it. Okay, well, something happens. The water is actually able to absorb heat from the surroundings. So the water is able to take in this heat energy from the surroundings. Which means, well, it means on a hot day, the particles are going to have more energy. So you can see straight away I'm using the information that's given me in the question. I'm discussing a hot day, how it compares. So a hot day, the particles will have more energy. So something happens which has an effect, which means, well, more particles will have enough kinetic energy to evaporate from the surface of the water. Therefore, well, the water evaporates faster.
Question 10a. A freshwater lake is an example of an ecosystem. Use the words to complete the definition of the term ecosystem. Each word may be used once, more than once, or not at all. Okay, so we have a selection of words under here. So looking at the definition, an ecosystem is a unit containing all of the organisms. Not just the animals, not just the plants, not just the prey. It's everything. And their environment. Interacting together in a given area. It's not just their homes where they live. It's not just their food. It's not just their prey. It's absolutely everything. So the ecosystem includes the plants, the animals, the bacteria, all the living organisms, and the environment, and their environment, which includes the homes, the prey, the predators, the organisms, everything in the area. Okay, interacting together in a given area. All right, good. B. Figure 10.1 shows part of a food web from a freshwater lake ecosystem. Okay, we have pondweed, we have microscopic algae as producers, then we have mayfly nymphs and freshwater shrimps as primary consumers, dragonflies, and brown trout as secondary consumers. And brown trout can be a tertiary consumer. Okay, let's see. Explain why brown trout can be described as feeding at the 3rd or 4th trophic level. Okay, so brown trout can be at the 3rd trophic level because they can eat the microscopic algae, the freshwater shrimp, and then they are at the 3rd level. Or they can be at the 4th level because they can eat the pondweed, then the mayfly nymphs, and the dragonfly nymphs, and they're at the 4th level. Okay, so the brown trout eat dragonfly nymphs, which eat mayfly nymphs, which eat pondweed, or the brown trout eat freshwater shrimp, which eat the microscopic algae. Or the brown trout eat the mayfly nymphs, which eat the pondweed. Or the brown trout eat the mayfly nymphs, which eat the microscopic algae. Or the brown trout eat the dragonfly nymphs, which eat the freshwater shrimp, which eat the microscopic algae. It's a web. That's the way webs work. But there's only 3 or 4 levels for the brown trout. Okay, so at the 3rd trophic level, the brown trout eat the mayfly nymphs or the freshwater shrimp, which both eat producers. At the 4th trophic level, the brown trout eat the dragonfly nymphs, which eat the primary consumers. So primary consumers obviously then eat the producers. All right, good. C. This food web has 4 trophic levels. Explain why most food webs do not have more than 5 trophic levels. Well, the reason for this is energy. Basically, at every level, there's a lot of energy lost. So in order to feed the top organism, there has to be enough energy left so it can survive. Okay, so there's a lot of energy lost between every trophic level by things like respiration, not all organisms are eaten, etc. This means that there's not enough energy left to feed a 6th level. All right, good. Now chemistry. Question 11. The chemical symbols of a chlorine atom and of a bromine atom are shown below. The symbols include the atomic number and the mass number of each atom. Okay, we have chlorine with a mass number of 35, an atomic number of 17, and bromine of a mass number of 79 and an atomic number of 35. Okay, the atomic number also can be called the proton number. All right, so state the number of neutrons in the bromine atom. So in the bromine atom, the mass number includes the protons plus neutrons, and as the atomic number can also be called the proton numbers, that includes just the protons. Okay, so that is 79 minus 35, which equals 44. And state the electronic structure of a chlorine atom. So a chlorine atom has 17 electrons, and those are arranged in the outer shells. The first one has 2, and there's 8, and there's 7. So 2 in the first shell, then 8 in the second shell, and 7 in the third shell. All right, and B, describe the color change when ethene is bubbled through bromine solution. Okay, so bromine starts off as an orange color. Ethene, when it goes through the bromine solution, the double bonds are broken by the bromine due to an addition reaction, so it changes from orange to colorless. Good. C, polymers are formed when monomers join together in polymerization reactions. Ethene reacts to form polyethene. Complete figure 11.1 to show part of a polyethene molecule. Your sketch should show 4 carbon atoms. Okay, so we have 4 carbon atoms in a row. Polyethene. Okay, we start off with this. Okay, ethene, each one has 2 H's attached. So ethene starts off as this. This is the original ethene molecule. Then the double bond is broken, and it just adds another. Double bond is broken, and it adds another ethene next to it. Okay, so each one of these has 2 H's attached. It doesn't get rid of any of the H's. Okay, and now what we need to do is we need to say that there's many, many, many of this chain. And so we say that there are n number of ethene monomers. Okay, 2, state the type of polymerization reaction that forms polyethene from ethene. Okay, this is called an addition polymerization. All right, good. 3, proteins are polymers found from amino acids. Describe one way in which protein molecules may be broken down to release amino acids. Okay, if you are talking about a more biology type of answer, which is okay because it's still the same, enzymes, specifically proteases, break down proteins to amino acids. Okay, that's one option. If you want to talk about a more chemistry response, because this is a chemistry question, you can say it's hydrolysis with an acid or an alkali. Okay, both of those would be okay, but it only says to choose one, so only put down one. All right, good.
12. Figure 12.1 shows 2 bicycles that are left outside on a sunny day. The bicycles are identical apart from the saddles. Bicycle X has a black saddle and bicycle Y has a white saddle. The saddle on bicycle X gets much hotter than the saddle on bicycle Y. Explain why this happens. Nice straightforward question. This happens, of course, because black is a good absorber of infrared radiation. B. Figure 12.2 shows a bicycle with a rear lamp A and a front lamp B powered by the same 9-volt battery. Figure 12.3 is a circuit diagram to show how the lamps are connected. Okay, so they're in parallel with 9 volts across them. Lamp A has a resistance of 8 ohms and B has a resistance of 16 ohms. Calculate the combined resistance of the 2 lamps in this circuit. Show you're working out. All right. So we've got resistors in parallel. 1 over RT is 1 over R1 plus 1 over R2. 1 over RT is then equal to 1 over 8 plus 1 over 16. Which which is, of course, 3 over 16. Which means that RT is given by 16 divided by 3, which is 5.33. And that continues on, obviously. So the resistance here, you could put 5.3 ohms. Oh, units are already there. You could also, because you got, I guess, one significant figure, write 5 ohms, that's absolutely fine. You wouldn't go and write 5.33 ohms, too many significant figures. 2. Calculate the current passing through lamp A. Right, state the formula that you use and show you're working out. Well, current passing through lamp A, we need V equals IR. Of course, rearranging that will tell us that I equals V over R. It's in parallel, so both of them have access, both the lamps have access to the maximum voltage, which means the current is then given by 9 volts divided by 8 ohms, which is the resistance of lamp A. That gives us 1.1 amps. And again, the units are already there. C. The bicycle lamps emit energy as visible light and infrared radiation. These are both parts of the electromagnetic spectrum. Place visible light and infrared in their correct positions in the incomplete electromagnetic spectrum in figure 12.4, so the one just underneath it. Alright, we've got UV here, visible light goes here, and next to that we've got infrared radiation. There we are. Excellent. 2. The speed of infrared radiation in air is 3 times 10 to the 8 meters per second, 300 million meters a second. The wavelength of the infrared radiation emitted is 750 nanometers. Calculate the frequency of the infrared radiation, state the formula you use, and show you're working. Okay. So for a wave, speed equals frequency times wavelength. You want to find the frequency, so frequency is then given by speed divided by wavelength. So that will give us 3 times 10 to the 8 meters per second divided by 750 times 10 to the negative 9 meters, which gives a value of 4 times 10 to the power of 14 seconds to negative 1, which is of course hertz, and doesn't really matter because the unit's already given to us. So 4 times 10 to the 14 hertz. And part 3. Gamma radiation may be released from the nuclei of atoms when they decay. Alpha particles and beta particles may also be emitted. State which radioactive emission, alpha, beta or gamma, is the most ionizing. And the answer here is alpha. It's the most ionizing, that's why it's the least penetrating. It loses all its energy ionizing things before it really gets anywhere. So there we are. That's it.
And question 13, figure 13.1 shows a diagram of the alimentary canal and associated organs. A. State the letter in figure 13.1 that identifies the liver and the pancreas. Okay, so the liver is this organ right here. Nice big organ, has a bile duct attached over top of the stomach. Okay, and the pancreas is this organ right here underneath the stomach. Okay? So the liver is A, and the pancreas is D. B. When a person eats a meal, the concentration of glucose in their blood increases. The pancreas detects this increase. Describe how the pancreas and the liver bring the concentration of glucose back to normal. So first of all, the pancreas releases insulin when it detects that there's glucose in the blood, and then the insulin causes the liver to change the glucose into glycogen. So the pancreas releases insulin when glucose is in the blood, and insulin causes the liver to convert glucose into glycogen. C. State a term that can be used to describe the control of the concentration of glucose in the blood. So the control of it, that is called negative feedback. Okay, so when the concentration gets high, it's brought down low. When the concentration is low, it's brought up higher. And D. Glucose is a carbohydrate. State the chemical elements contained in glucose. Okay, so glucose contains carbon, hydrogen, and oxygen. And that is the end of this paper. I hope you found this useful. If you did, please click the thumbs up to like, and please subscribe. And if you have any other questions or comments, we love to hear what you have to say down below in the discussion section. And have a great day.